All right, welcome everybody. Let's do this. The power rule. So, if we have some function x to the n, how do you take its derivative? It's n. So you bring this n over here, right? N times x to the n minus 1, right? And you subtract the minus 1 up top. So, how do we find the derivative of this one? If you want, take your time and calculate the derivative of each of these. But if you want to see the solution, this one will be 7x to the 6. This one will be 20x to the 5 minus 1 is 4. And then here you take the derivative of each of them. So this becomes 6x plus 5. And that's it, right? Because just real quick, for this one, 2 times 3 is x. And then 2 minus 1 will just be x to the 1. But remember, x to the 1 is just equal to x. Here, if I have the derivative of 5x is just 5, because here, there's a 1 here, so you're doing 1 times 5 is 5, and remember, you're doing 1 minus 1. So what's 1 minus 1? You get x to the 0, and x to the 0 is 1. So there is an x to the 0 here. It's invisible, but yeah, it just becomes 1. And the derivative of any coefficient is 0. So this negative 7, just you get rid of it. Here, let's look at x to the negative 2. It's the same idea as here. Don't freak out just because there's a negative. It's just negative 2x. Now, what's a negative 2 minus 1? It's just negative 3. But then I want to convert this to negative 2 over x over 3. Because here, x to the negative 3 is equal to 1 over x cubed. And remember to have it in positive exponents always. Let's look at this one. Here, you're just doing 2 times, here you're doing 2 times 3 over 5, right? So that just becomes 6 over 5, and just an x, because 2 minus 1 is 1, so that's just an x there. Okay, so then you're thinking, oh, Mr. G, these are light work. I'm really comfortable with these. Well, some of them, we got to get used to the radicals. So here, what we're going to do is we're just going to review some Algebra 2 skills to remember, and hopefully for the rest of your life. But here, how do you express this radical expression as some exponential expression? Here, square root of x will just be x to the 1/2, right? Yeah, let me zoom in a little bit. Okie dokie, okie dokie. Here, cubic root of x will just be x to the 1/3. This will be x to the 1/4. Notice that the index or the radicand over here will always be in the denominator. So here there's that invisible 2, so it's just 1 over 2. This is just 1 over 3. This is 1 over 4. Whatever's on the outside here goes into the denominator of the fraction. And now let's take a look at this one. Here, notice that this one, there has to be a 2 on the bottom, right? Because it's a square root. There's that invisible 2. But where does this 3 go? It just goes up top here. What about this one? If you want, take your time and just do it very quickly. But here, what does this become? This becomes x to the, what goes on the bottom, the 3, and what goes on top, the 4. And what about here? What goes on top, the 100, and what goes on bottom, the 7. And that's how, and it's vice versa, right? You could go from here to here, or you could go from here to here. They're both equal to each other. And what's the purpose of changing this expression to look something like this? It's because when we take the derivative and we want to take a minus 1 for the derivative up here, we need the exponents in some form that's not within a radical expression. Okay? Let's look at the next part over here just to remember. Here, notice that 1 over x squared is the same as x to the negative 2. Okay? That's just a rule. Here, if I have x to the negative n, it's equal to 1 over x to the n, right? And you could go the same way over here where you could go vice versa, right? You could go vice versa here. So like, remember that 1 over x squared is the same as x to the minus 2. So you can go this way, or you can go this way, right? So they're both equal to each other. And that's what we're going to need to do when we have some more difficult functions and we want to take the derivative. So here, why don't you take your time and try and find what these are equal to. Okay? If you want, pause the video. But here, this is just x to the minus 3. This will be 2 times 1 over x to the 3, but then that's equal to 2 times x to the minus 3. Okay? This one will equal to 1, let's see, this is 1 over x to the 1/2, but then that's equal to x to the negative 1/2. Okay, you see how I changed this square root of x to x to the 1/2? And what did we do? We just did that rule we did over here, right? There's nothing different, it's just a 1 over. But because it's a 1 over, right, it's the same idea here. Like just like 1 over x squared is x to the negative 2, 1 over x to the 1/2 is the same as x to the negative 1/2. All right, and this one here, you know, take your time. This is equal to 1 over x to the 5 over 3. But because it's 1 over, you're allowed to say this is equal to x to the negative 5 over 3. Okay? Hopefully this helped as a warm-up, because now this is where we take the derivative of some more challenging examples. So what I want you to do is, with your new skills that you just picked up right here and you just practice, what I want you to do is try and find the derivative of this all by yourself. Okay? All right, so how do we actually do this problem? Notice that this is equal to 5x to the minus 1. Okay? Now that you have this in this type of form, now you see, like, getting this into this form is the tricky part, because once it's in this form, then we could just do our derivative rule, right? It's just n, the n goes to the here, and then the n minus 1. So here, this just becomes, what does it become? It becomes negative 5x to the negative 1. And then what happens here, there's a minus 1, okay? And then this becomes negative 5x to the minus 2. The whole thing is to the minus 2, not just the x. So then this becomes negative 1 over 5x, the whole thing squared, and that becomes negative 1 over 25x squared. Okay? Now I know this, I may have done this very fast, so take your time and be patient. And if there's any questions, you could always raise your hand and ask me. Okay? Next one. Here, let me zoom in a little bit, better camera angle. Okay, so now, what are we gonna do for this one? Pause the video, right? Remember, try and change this to some, you know, how did we, let's see, right? How did we change these, right? We use these types of tricks, right? Try and use these tricks to change this and then find a derivative, okay? So let's see. This is equal to negative x to the 5 over 2, right? Over 2. Okay, so this is just x to the, because here this 5 goes on top, and because it's a square root, the 2 goes on the bottom. And now here what I could do is, I could take this now notice that there's a negative half here. So what I'm going to do is I'm going to take the negative half times just an x to the 5 over 2. So this is the kind of trick you need to do, is you need to take this negative half out, and now we're just going to take the derivative of this guy here. So what's the derivative of this? So this negative 1/2 stays. What's the derivative of this guy here? It's just 5 over 2, because remember, you just multiply this down, times x to the 5 over 2, and then what do we need to do? We need to do a minus 1, okay? All right, so this negative 1/2 stays. Right? And one little thing that I remember I saw another student do, they said, oh, mister, the derivative of a constant is 0. Yes, but you're not taking the derivative of this, you're taking the derivative of this guy. Here, you're just taking the constant down. Right? So then this becomes 5 over 2 times x to the 5 over 2. And then what do you convert this minus 1 to? You convert the minus 1 to minus 2 over 2. Because if you want to subtract these two fractions, the denominator has to be the same. So then what happens? This becomes negative 1/2 times 5 over 2 times x to the 3 over 2, right? And then this becomes negative 1/2 times, right, 5. And then now you want to convert this x to the 3 over 2. You're going to express it back into a rational form. I'm sorry, a radical form, and it's just like that, right? Pause the video and take your time and see why this becomes this, okay? Because here, remember, this 2 is the radicand over here, and this 3 goes on the inside for the exponent of the x, and this 5 over 2 stays, right? For something like this, you got to go everything step by step. You got to take your time, okay? And then now we're going to multiply this negative 1/2 back into here, so it's negative, and then what's on the top? 1 times 5 is 5, radical x cubed over 4, and that's it, okay? So what I want you to do is take your time and try and do these problems by yourself, okay? Take your time and you got this, okay? The first move is, let's take out this negative 2 over 5, right? Times, and then how do you convert this? This will be x to the 5 over 2, okay? Oh, I'm sorry, not 5 over 2, 5 over 3, right? Because there's a cube that's part of the, it's part of the radical, not part of the negative 2, okay? And it's the same idea we had over here, right? We're gonna take the derivative of this guy and leave the negative 2 over 5 out. So this negative 2 over 5 is on the outside, and now we want to take the derivative of this. So this becomes 5 over 3, x to the 5 over 3. Now we need to do a minus 1, okay? And then this becomes negative 2 over 5, 5 over 3, x to the 5 over 3. Now, how are we going to convert this minus 1? It's going to be minus 3 over 3. Because we want to make sure that these two denominators are the same, right? So then this becomes negative 2 over 5 times 5 over 3, x to the 2 over 3, okay? Then what happens here is this becomes negative 2 over 5, 5 over 3, and then this x to the 2 over 3, what does it become? It becomes the cubic root of x squared, okay? And then what do we need to do? We just need to multiply this, and this becomes negative 10 to the cubic root of x squared over 15. And then what can you do here? You can simplify this fraction if you want, and it becomes negative 2 cubic root of x squared over 5. All right? This one was a tough one, but it wasn't impossible. Try and do this question by yourself, and also try and do this question by yourself. And what we'll do is we'll explain them in class. I hope this helped. See you.